last video we talked about general terms. General terms are basically a way to write a whole sequence with one term. So let's look into some specific examples. This is going to be an arithmetic sequence. And the instruction will say something like, find the general term for, and then they'll write out 3, 7, 11, ... They put the ellipses because it can go on forever. Now when they say general term, they want a formula a sub n. So if I give you any n, if I wanted to find the 100th number, I could just plug in 100 and get the answer. So let's think about this. We start with 3. So a sub 1 is 3. Now think of the other ones in relation to this one. What's happening between each step here? Well, it looks like we're adding 4, we're adding 4, and so our common difference is 4. Now even though a2 is 7, we have to think about how we got there. So it's like taking a1 and adding 4. So we could think of it like start with the first term plus 1 common difference. And that would get us 7. Let's think about the next term. Yes, even though a3 is 11, we have to think about it like if we started at 3, what we're doing is we're actually adding 2 4s to get 11. And I'm trying to recognize this pattern because when I write out the rule, we're always going to start with the first number in the sequence. We're going to add the common difference, which was 4 here, but we're not going to add it, like here we're not going to add it 2 times, here we're not going to add it 3 times, it's actually 1 less because we've started already with 3. So to adjust that, we're always going to multiply by 1 less the number. And if we want to try testing this out, you could plug in 3 here. You would get 3 minus 1 is 2. 2 times 4 is 8. 8 plus 3 is 11, and it would work out. Okay, so here is the general way to do it. This is our answer for this question. But to find the general term, you're going to write basically the first term plus the common difference n minus 1 times. And that will be how you could find the arithmetic every time. Now, just beware. The book is not always going to write it like this. They might write it after distributing the 4 and simplifying. So this is going to be negative 1 plus 4n. I personally will not require this, but sometimes that's in the answer key. Alright, so I'm going to give you one to try. Try finding the general term for 17, 11, 15. That's going to be a 5 right there. ... The directions will normally say find a sub n and something like a sub 150. Alright, so here's what we should have thought. Looking at the differences here, we're going down by 6 every time, and that's our common difference. So, to find the general term, we're going to start with the first number, and then n minus 1 times the common difference. Now that right there is perfectly valid, but I am going to simplify it. I'm going to expand out the negative 6. 17 plus 6 is 23, so it's going to be 23 minus 6n is our general term. And now if I plug in like 1 for the first term, 23 minus 1, 6 is 17. If I plug in 2, 23 minus 12 is 11. Seems to be checking out. Now to figure out a sub 150, all we have to do is figure out, well, 23 minus 6 times 150. That jumps us right to the answer, so that's going to be 23 minus 150 times 6, negative 877. That's the second part of our answer. Alright, so arithmetic is not the only sequence out there. We also have the geometric sequence. And it's kind of the same principle to find the general term. So I'm giving you a particularly scary looking sequence. Now from the way it's written here, it's kind of hard to see that it's geometric. The directions will say like find a sub n and a sub 10 to 5 decimal places. Alright, so like I said before, if you're having trouble seeing what you multiply this to get that, you could divide backwards to figure out the common ratio. And one important thing here is that you divide a couple times to make sure that that ratio is the same, that it's common. So I'm going to do 3/2 over 2/3, which is the same as 3/2 times 3/2. I keep and flip the bottom and multiply, so that's 9/4. Okay, that should be my common difference, but let's check the other one. If I do not get the same common ratio, that means that there's something wrong and this actually isn't geometric. But in this case, it'll come out. Let's just do the work here. Whoops. Nope, that's right. 2/3. That's 54/24. If I divide by 6, I get 9. If I divide by 6, I get 4. Alright, we've confirmed that there's a common ratio. So here's how we think about the general term. Just like in the last one, we think, well, we started with 2/3. And every single step I move forward, I'm going to multiply by 9/4. But if I plug 1 in, I haven't yet multiplied by 9/4. So if I plug 1 in, I want it actually to be 0/9/4. So this should be n minus 1. If I plug in 1, it's actually going to be 9/4 0 times. So it's just going to be 2/3. If I plug in 2, I should get 2/3 times 9/4 once. That's why there's a 9 minus 1. So to figure out the a to the 10, we're going to be writing 2/3 times 9/4, and it would be 10 minus 1, which would be 9. Now, a lot of times, you will need like a decimal for that. So I'm plugging that in my calculator now. I am getting, it looks like 985.26125, rounded to 5 decimal places. Now, something to note here. If you look at the limit of an here, limit of this guy right here, as n goes to infinity, just realize that we're multiplying by 9/4 every time. And if you multiply by something that's bigger than 1, it's going to get larger and larger and larger. And so we know that this is going to diverge. Alright, so give this one a try. Here is I'm telling you it's a geometric. Find a sub n, and then find a sub 20 to 5 decimal places. Okay, so first we have to divide backwards, because I know there's a common ratio, and if I can't think of it just by looking at it, I should divide back. 12 over 16 is, well, divide by 4, you get 3/4. 9 divided by 12, if you divide by 3, you get 3/4. Common ratio is right there. The general term is going to be the first number times our common ratio, but always 1 less than the actual index. By the way, that n can be called the index sometimes. Alright, and then a 20 is going to be 16 times 3/4, but 19 times to get to the 20th spot there. Alright, now that is going to be 16 times 3/4 to the 19th power, 0.06765. Now think about it this way. This guy right here, because it's less than 1, it's going to make the number that we start with smaller every single time you go to the next term. So if we were talking about limit here, oops, the limit would not be increasing every time, it would be decreasing, but it would never quite hit 0. So as n goes to infinity, our limit here would be 0. It's kind of like that story about the ancient Greek, name escapes me now, that if you go halfway to a wall and then you go halfway from the halfway point. You will never actually quite hit the wall, but you'll get as close as you want. That's the limit. The limit is 0.